Today, we will find out how to make power grids ready to support more renewable energy sources while keeping the costs low. To understand how power grids can get ready for more renewables in a cost-effective way, I'll now talk to Dimitris Lagos of the National Technical University of Athens in Greece. Hi, Dimitri. Thanks for joining us again.
Hi, Hannes. Thanks for having me.
Dimitri, I have the feeling that renewable energy sources are nowadays literally everywhere, but there are still many discussions around power grids being under pressure due to additional renewable energy sources being installed. How about these issues? Is this real?
Yes, of course, it is. That is correct. As renewable penetration increases, more and more system operators have observed critical issues that could affect the security of power supply. For example, in Greece, we have some weak systems, non-interconnected islands. In there, there is an actual constraint on how much renewables you can add because were a lot of blackouts and issues that have occurred due to high renewable levels. Apart from Greece, we can go to the cases of Ireland or Australia, which have larger power grids, but not as stiff as the European grid. We can see that these operators have more strict code and more requirements to their operation to avoid issues caused by renewable penetration. And we can see also that they are testing new technologies in order to see how they can proceed to greater renewable penetration levels. Eventually, every system operator will have to do upgrades in their system and in terms of lines and transformers, but also adopt new technologies like energy storage and grid-forming inverters. A combination of that will allow them to take the renewable penetration a step further and overall achieve greater levels than the ones that we have now.
What or which specific challenges do power grids face when trying to increase the use of renewable energy sources?
I would say it depends on which part of the system do you see. For example, for the transmission system and the transmission system operator, a major concern is the reduction of inertia. When you install renewable sources, you replace conventional generators. And the conventional generators operate with synchronous machines that have spinning pads that add inertia to the system. This is not the case for renewables. They are connected through power electronics. They do not add any inertia to the system. And this inertia reduction makes the frequency control of the system very more difficult. So the system operators are looking for ways to make the system more stiff, make the renewables add in a smart way inertia or services that can help the frequency control. So there are also other issues in the transmission system like congestion or power quality. From the distribution system side, which is the scope that we see in OPENTUNITY, I would say that congestion in lines, if you have high amounts of renewable production compared and low load levels, could occur. And this is one issue. And the other issue is the voltage rise. If you have a surplus of renewable production, the voltage rises in the system, and if it exceeds the level, it could cause damage to equipment, both in the grid, but also to the consumers.
You're working on algorithms that can solve many of these challenges. Can you explain us what these algorithms exactly do, and how does it make the integration of renewable energy sources easier?
Sure. Okay, it's a set of tools that part of one solution that help the system operator decide what is the best upgrades in their system. So in the first level, we get the load and renewable data that the DSO provides and run through a fast computational algorithm a lot of power flows of the system. So this helps us identify if there is an issue and at which components of the system. And the next step is to run an optimization in certain scenarios to see whether which upgrades should be made in the most efficient manner in the system to avoid having, let's say, the limits in lines or in the voltages in the buses exceeded through the renewable penetration.
On the one hand, there are distributed energy sources which depend on sun and wind, and on the other hand, there are energy users, who have a certain flexibility regarding the exact point in time when they use which amount of energy. Do these two sides play together in your solution?
Yes, that is correct. I mean, one of the great benefits of using flexibility is to avoid investments in the grid. So usually you don't have, let's say, problems in the grid throughout the year due to renewable penetration. You have it at certain hours. If you can deal with it at that hours with flexibility, you can postpone investments in the grid by some years, or wait and see if you actually need an upgrade if you are dealing with flexibility. What we have built is in our optimization model is also it considers flexibility, so it can optimal select which of the options to enable, either use flexibility to avoid grid upgrades, or if the flexibility is required a lot of the time, maybe switch to an upgrade in the system because it might be more cost efficient.
Your algorithms integrate advanced optimization techniques that also ensure cost efficiency. In simple words, how does this work? Can you identify the most cost-effective next action to improve the grid and make better use of renewable energy sources?
Okay, so how this works? It's mathematical formulation. So you have several scenarios uh, with renewable generation and loads. And in the algorithm, you set the equations that has to do with the power flow in the system. And you are trying at the same time to minimize the costs related to the operation of the system, which can be power losses, renewable curtailment due to, let's say, congestion, load shedding for the same reasons. And also you're trying to minimize the planning cost, the capital cost that you spend to install new equipment. So this formulation basically tries to minimize this cost and selects the optimal way to do it. Either if it realizes, for example, that if you activate flexibility, you deal with all the concerns, it does not suggest to install new equipment because it's not cost effective. But if it sees that the new equipment is required to avoid renewable curtailment or load setting, it's also suggested, and to avoid the issues that I mentioned that can lead to renewable curtailment or load shedding.
Later this year, you're going to roll out your algorithms in certain regions in Greece and Spain. Can you share any insights into specific challenges that distribution grid operators are currently facing there?
I would say that right now they do not face much so severe challenges. They have observed issues in their systems, but they are not already in a situation that the threats are to great extent. But that doesn't mean that it won't be in 3 or 4 or 5 years. So basically, both operators want to see how they can spend their budget for upgrades in the most efficient manner through our tool to see where it is the best way to spend their budget in order to have the greatest impact on renewable hosting capacity in their systems.
Uh, can other grid operators integrate these algorithms in their network planning processes already?
Uh, Other operators probably have already some kind of network planning processes. Usually they have softwares that perform exhaustive simulations and heuristic approaches to find what is the replacement. What we are building in OpenTunity will have an interface that allows to pass topology data through a standardized format that system operator uses, like CIN format. And I would say that it is pretty straightforward for other system operators to integrate these tools to their operations.
So when grid operators optimize their grid upgrades in terms of cost efficiency, do you think it will speed up the decarbonization of the energy system?
Of course, of course. Optimizing the upgrades and the most efficient manner will have the greatest impact in terms of renewable hosting capacity, because they are spending their money at the places that is the most needed and will have the greatest impact. So they will replace the equipment that will allow greater level of renewables and other equipment that will pose the constraints to further rescue utilization, but and taking also consideration flexibility. So they have also another solution to deal with the issues that rise through renewable penetration, and through our tools, they will find the most cost-efficient way to see how to deal with the issues, either with flexibility or grid upgrades in various sections of the system. So I guess such tools in the future can help increase the renewable hosting capacity of systems.
Okay, finally, again, we look into the future. What would you say? What future advancements do you expect in this kind of technology, and what aspects are you most excited about?
Okay, as I said, system operators usually do some heuristic approaches with high computational burden to check every scenario and decide whether to proceed with an upgrade. So such tools for planning that use optimization, I would say that in the future they have to take into consideration flexibility and overall the energy management algorithms that the system operators will use in real time in their system. So this is a very critical aspect that will also have a research spotlight on it in the future. But I would say also another aspect that would be exciting in terms of network planning could be how you deal with uncertainty. For example, if you look many years in the future, how you deal with prices and their uncertainty, how you deal with consumer behavior and the load growth that you expect and the uncertainty that this has, or the future capital costs. This is also a very exciting field, and I think that it will get a lot of attention initially from research and hopefully from industry in the future.
Wow, that's really awesome things to come, I see. Dimitri, thanks a lot for joining and for taking us on a tour to this exciting field today. Thank you very
Thanks,
much.
thanks a lot, Hannes. Bye.
Did you enjoy our interview today? Give us a thumbs up and subscribe to our channel for more insights into smart grid technology and integration of renewables.